Science on Surfaces.
Welcome to this podcast. Today we will talk about adhesion. We will talk about what adhesion is, when and why it is important, and what different factors that affect the quality of the adhesion. Here with me in the studio I have Susanna Lauren, who is an expert on surface-related phenomena such as wettability, surface tension, surface free energy, and also adhesion. Susanna's been working at Biolin Scientific around these topics for over 8 years. And before that, she did her Ph.D. on microfluidics and superhydrophobic surfaces. Welcome.
Thank you.
So just let's dig into it and start with the basics. What is adhesion?
So adhesion is attraction between two dissimilar phases. So American Society for Testing on Materials, so ASTM, actually defines adhesion as the state in which two surfaces are held together by interfacial forces, which may consist of valence forces or interlocking forces or both. So this basically means that, there is no actual good definition for adhesion as such, but it's divided typically into mechanical interlocking, physical and chemical bonding. So with mechanical interlocking, I really mean that the adhesive material will fill all the voids and pores of the surface, and the two surfaces are really mechanically hold together.
Okay, so you have the material fills a void, and then when it's goes from a solid to a
from
a liquid to solid, then there is no way back. So to say.
Exactly.
It's kind of stuck.
So this is basically how many of the glues work.
Right.
So you have a glue that is kind of flowy in the beginning, and then it dries out, or you might have like two component glues that you need to mix together to get the curing to in place. So that's probably one of the most important mechanisms of adhesion as such. Then we have physical adhesion, which is always present. I mean, it's based on the van der Waals forces in between different materials. Mm-hmm. But these forces are very weak. So as such, they are not really, they are not able to form a very strong adhesion between two materials. Then we have chemical bonding. So this includes all kinds of covalent, ionic, metallic bonds that we have. I mean, for example, in a piece of metal, you have metallic bonds between the metal atoms. And they are actually usually quite strong bonds. But and if you would get this chemical bonding, that would mean that the interface almost disappears between the two different materials. But this is very difficult to achieve with two dissimilar surfaces. So you can, of course, imagine that it's quite difficult to get two different materials to bond so that you don't even see the interface anymore.
Right. So there are these three sort of possible components that could be present in the adhesion.
Yes, exactly. So it's of course usually a mix of, especially the mechanical interlocking and the physical adhesion, and then maybe in some cases also chemical adhesion.
Okay, so why is adhesion important? I mean, the glue situation, that's kind of an obvious one.
Yeah.
But other situations.
Yeah, so I mean, yes, gluing is of course something that you do on your, even in everyday life, you might want to glue things together. And I mean, the other very obvious example is painting, for example.
Right.
So if you paint a wall, that is basically adhesion between the wall and the paint that you are applying to.
Right.
And then we have, for example, in packaging, adhesion is very important, because there you have, if you think about a milk carton, for example, it's actually composed of several different layers of materials. So you have polyethylene layer, which is basically a plastic or a polymer layer. Then you have aluminum foil. Then you have the paperboard, and all of those layers need to stick together,
right?
So that they form a product or a package that actually works,
right?
How it is supposed to work. And then if you think about it, still the packaging, you usually want to print something on that package. So you want to highlight the name of the product, tell the ingredients of the product. So then you need to print something on it. And that's again an adhesion issue between the material that you are printing and the ink that you are using to print. And then adhesion is also present in completely different areas, like in biomaterials, where you have adhesion between cells and biomaterial surface.
Right.
And there is of course other things also affecting on that. So you can't really say that it's only like mechanical interlocking or physical or chemical bonding. So there are other things that affect in that situation, but the mechanisms as such are kind of similar.
So would this then be basically any situation where you have two materials that should be in contact and stay in contact without any sort of external force?
Yeah, exactly. Yeah. And then basically how good is the adhesion? What kind of forces are there at the interface define the strength of the adhesion?
And these situations we basically have everywhere.
Yeah, exactly. Absolutely.
Yeah. Okay, so then what factors affect the quality of the adhesion?
I would say probably the most important one is clean surface. So if you think about if you have any kind of contamination on the surface, that usually means that you have lower surface free energy on the surface, and that will then make it more difficult for anything that you want to spread on it to spread and then stick on the surface. So if you think about something that you would, if you would touch some surface with your fingers, you would add grease on it, and that would be contamination. So everything usually starts with clean surface. That's probably the most important one. Then that is kind of related to the wettability of the surface. So I mentioned the surface free energy. So, if you are applying coating on the surface, you want it to spread on it. And as I mentioned, if you have if you have high surface free energy on the surface, it's more likely that whatever you are applying on it will spread on it. So this in the good wettability is always important when you want to have, especially for example in paints, if you want to have the paint to stick.
I'm thinking about this. Sometimes you want to write something with a pen on certain materials, and the ink will just roll up.
Yeah, exactly.
It's just impossible to use it.
Exactly.
And then you kind of have an idea of what kind of pen that will work and which will not work.
Exactly. Yeah, that's quite a kind of practical example on that. And then then wettability and adhesion as well then is also affected by roughness. So if you think about, usually mechanical interlocking, you need some kind of roughness so that you can get that glue, for example, to stick. Basically,
I'm even picturing that you need some sort of almost like an entry hole.
In a sense, yeah. But
with
then
like a bigger void behind.
Yeah, exactly. But then if you would have those and you would have poor wettability, so that whatever you are applying doesn't want to go into those holes, that would actually make the adhesion really, really bad, because then you would basically have like air pockets in between the substrate and whatever you are applying on top. So that's why roughness can be good for adhesion, but it can also be very, very bad if the wettability of the surface is bad.
So with a good wettability, you will get a bigger contact area with the roughness.
Yes, exactly.
And with bad wettability, you would have a lower contact area.
Exactly. And also, I mean, the roughness also adds the possibilities for physical bonding.
Right.
Because, I mean, of course, I said that they are weak, but if you have, weak forces, but if you have a lot of them, then they start to make an effect as well. So, and then maybe the last thing is also, I mean, we've been talking a lot about how the surface has to be in order to get good adhesion. But then there are, of course, some requirements for whatever you are applying on the surface as well. Because if you think about paints, the viscosity of the paint should be low enough so that there is some kind of a flow. Because, I mean, of course, you need that flow to be able to for the paint to penetrate into those voids.
Right.
I mean, if you would have like a paste, then you can imagine that it would be quite difficult to to cover the whole wall with some kind of a paste-like material.
Yeah. It would be. So you mentioned cleanliness is important, roughness, and then the thing you want to coat with.
Yes.
They are all affecting the quality of the adhesion. Is there any of these factors that is more important than the other, or?
I think wettability is probably one of the most important ones. That is really kind of what defines or dictates how good the adhesion will be. So that, and I mean, cleaning, you can't really say that. I mean, cleaning is of course important, but that's also in a sense related to wettability. So,
okay. So what can you do to improve the adhesion then? Clean the surface, of course.
Yeah. So I mean that's kind of given. So I mean if you paint something at your house, you are always advised to clean the wall first. I mean, I don't know if everybody does that.
I don't.
Yeah, exactly. But you should do it.
Yeah.
But luckily the paint manufacturers maybe know that, because they know that people are lazy and maybe don't do it, and usually the paint sticks quite well anyway.
Yeah.
But you should do it in order to improve the adhesion, and usually that is enough. But then in some cases you might need some undercoat layers, for example. So it's some
sort of primer.
Exactly. Different type of primers are basically used to improve the adhesion. So improve adhesion between your substrate and whatever you are then like the outermost layer that you are applying to. And then, so you're basically, before coating, you are making the surface free energy as high as possible, so that what you are putting on top will spread on it. And if you think about industrial processes, then it also starts with cleaning, typically. I mean, because if you have any type of contaminants, they are quite likely to decrease the surface free energy of your surface. But if we think about this packaging example that I discussed, there you usually want to put together some type of a polymer surfaces, and those surfaces typically have very low surface free energy values. So it's quite difficult to stick anything on those. I mean, if you try to glue plastic together, it's quite difficult.
Yeah.
So you usually need to do some type of a surface treatment on that plastic to increase the surface free energy of the plastic before you apply the coating. So so plasma treatment is very often used in packaging.
So that's a known method for increasing the surface free.
Yes, exactly. So you plasma treat or flame treat your polymer surface, which then increases the surface free energy of the polymer.
So what is flame treatment? Is that with fire?
Well, not exactly.
No.
It's so basically all these treatments are kind of like high energetic bombardments of the surface with some ions with high energies. Okay. So, but those are basically used to get to the situation where you have higher surface free energy, and then it's easier to apply your adhesive on top.
Right. So that will basically help in two ways then, I guess, because you have no contaminants in the way.
Absolutely.
To ruin.
It can also be kind of like a cleaning procedure, because bombarding your surface with ions will also remove whatever contaminants you might have there.
And it helps also with the interaction of whatever you put on top.
Yeah. And also what could be, this is, it depends a little bit on the material, but this could also add a little bit of roughness on your surface. So that is also something that is kind of always present when you think about your adhesion problems. Basically, you need to kind of take into account what is the wettability of the surface, and then what is the roughness of your surface, because they both matter in terms of adhesion strength. Right.
So can you measure the adhesion somehow?
So there are basically, you need to a little bit separate it to measure adhesion. Yes, you can measure in some ways after you have applied the coating, but then you can also before you even apply the coating, you can try to basically optimize.
Right, so you can predict how well a material will adhere to.
Yeah, exactly. So if we think about this, so you typically predict it through wettability measurements, so through contact angle measurements. And as I was talking about the plasma treatment, one quite common way, because it's very known that plasma treatment can be used to increase the surface free energy of polymers. So quite often what is really actually done is that, in the beginning you optimize the plasma treatment time by measuring contact angle, because depending how long you plasma treat, the surface free energy can either first maybe increase, but then if you do it too long, it starts to decrease again. Okay. So it's not, you have to find that optimum time that you should.
For each material.
Each material, yes, exactly. So it can be different depending on the polymers.
Would this be something that you can find in a chart or table, or will you have
I would say probably you can rely on previous knowledge, or you can of course just by testing different plasma treatment times. There are other factors like plasma treatment power, what type of gases you are using, and things like that will affect. So you can, if you have like your own polymer, you can of course optimize it for your own polymer by measuring contact angles or surface free energies and look where the optimum values are. But then when you know that, okay, I know that 3 seconds with this plasma, this power is good for my material. So what people are then commonly doing is that they just check the quality of the plasma treatment, kind of like a quality control of the plasma treatment. Just look at the contact angle after the plasma treatment to check that it has worked as you has predicted, and then that could be kind of on your quality control process as part of it. So those are of course quite typical situations where you would optimize the adhesion, and then you can optimize also the surface tension of your coating formulation, so that it matches the surface free energy values of your materials.
And then after, can you test how well it worked?
Yeah, that's actually quite tricky. So you can if you have already applied the coating, on the substrate, then it's quite difficult to, I mean, there are methods to do it, but it's not very straightforward. I mean, for example, because the failure mechanisms, like how, from what point the adhesion failure, I mean, it can be adhesion failure when it's like in between the substrate and the adhesive material, but it could actually also be within the adhesive. So that it's not really related to your to the adhesion itself.
So it's not at the interface.
Yeah, it's not interfacial failure. It's more like in the bulk. Or you can even have the substrate failure. So it's kind of hard to say where the failure has actually occurred. And then how to even do that? I mean, believe it or not, but the tape test, like just putting a tape on the coating and then pulling it out quickly. Yeah, that's kind of a quality control method.
See if the coating
if it sticks on the tape or on the substrate. Okay. But I mean, you can imagine that then the maximum kind of force that you can measure is of course dependent on how well the tape actually attaches on your coating. Of course. So then, I mean, it's not going to be very. You can't measure very high. I mean, if the adhesion is good, then nothing should happen. I mean, you can't get, hopefully, the paint out of the wall by putting. I mean, the paint out of the wall just putting tape there.
No, but essentially, you can only say the adhesion is stronger than the tape.
Yeah, exactly. Force, yeah, exactly. And you don't usually say any numbers. You usually just say pass or fail. Yeah. Because it's a quality control method, basically. Then you can use different type of scratch tests. So you have like a stylus that you pull across the surface and then put a load on stylus and that way get some kind of an idea what is the adhesion. But then you at least
have control of the force.
Yeah, exactly. Yeah, that's true. But yeah, I mean then, and people are of course using like electron microscopes and things like that to see where is the adhesion failure happening. As I said, it can happen in various different points. So there are methods, but it's not as straightforward as you would think, because I mean, you would think that there are lots of really good methods to do that, because it's something that is everybody are painting the walls or applying coatings.
Exactly. So. Yeah, that's so interesting. I mean, adhesion it's like a concept that we all have a relation to, I think, and it's like a very straightforward concept, but it's more complicated.
It is. Yeah.
Okay, so I think that's all we had for this episode. So thank you for listening to this episode with me, Malin Edvardsson, and Susanna Lauren from Biolin Scientific. And I would also like to take the opportunity to mention to those of you who are listening or watching that if you're interested in surface science and related phenomena, you should check out our blog, the Surface Science blog. Thank you.